in a 5 to 10 year time frame, quantum computing will break encryption as we know it today.
Hi everyone, welcome to my channel AI Fusion. Today I have a very exciting topic for you, how quantum computers break the internet and why no secret is safe now. You probably know that the internet relies on encryption, a way to scramble data so that only the intended recipients can read it. Encryption protects your emails, your online shopping, your bank accounts, and even your power grids from hackers and spies. But what if I told you that there is a new type of computer that could crack any encryption in seconds and expose all your secrets to the world? Sounds scary, right? Well, that's what quantum computers can do. Quantum computers are not like the computers we use today. They use the weird laws of quantum physics to perform calculations that are impossible for conventional machines. They can process huge amounts of information at once and find hidden patterns and shortcuts that normal computers can't. For example, quantum computers can factor large numbers very quickly. This may not sound very impressive, but it's actually the key to breaking most encryption schemes. Encryption works by using mathematical problems that are easy to do one way, but hard to undo. For example, multiplying two large prime numbers is easy, but finding the original prime numbers from the product is very hard. That's why encryption uses products of prime numbers as keys to lock and unlock data. But quantum computers can use a special algorithm called Shor's algorithm to find the prime factors of any number in polynomial time, meaning that the time it takes grows slowly with the size of the number. This means that quantum computers can break any encryption based on factoring, such as RSA, which is widely used on the internet today. How fast can quantum computers do this? Well, according to a report by RAND Corporation 6, a quantum computer with 4,000 qubits, the basic units of quantum information, could factor a 2048-bit RSA key in about 8 hours. A conventional computer would take 300 trillion years to do the same thing. That's not all. Quantum computers can also break other types of encryption, such as elliptic curve cryptography, ECC, which is used by Bitcoin and other cryptocurrencies. Quantum computers can use another algorithm called Grover's algorithm to find solutions to equations that are hard to solve backwards. This means that quantum computers can find private keys from public keys and steal digital money or forge digital signatures. How fast can quantum computers do this? Well, according to Google 3, their quantum computer called Sycamore achieved quantum supremacy in 2019 by performing a calculation in 200 seconds that would take the best supercomputer 10,000 years. That calculation was not related to encryption, but it shows the potential power of quantum computers. So what does this mean for the future of the internet? It means that we need to prepare for a milestone some call I2K, the year when quantum computers will be able to break the encryption that keeps our communication secure. No one knows when I2K will arrive, but some experts estimate it could be as soon as 2030 or as late as 2050. If we don't act before I2K, we could face a cyber apocalypse. Hackers could access our personal data, our financial accounts, our health records, our military secrets, and our critical infrastructure. They could blackmail us, spy on us, sabotage us, or even start wars. But there is hope. There are ways to stop quantum computers from breaking the internet. One way is to develop new forms of encryption that are resistant to quantum attacks. These are called post-quantum or quantum-safe cryptography. They use different mathematical problems that are hard for both conventional and quantum computers to solve. For example, some post-quantum schemes use lattice-based cryptography, which involves finding short vectors in high-dimensional spaces. Others use code-based cryptography, which involves decoding noisy messages sent over noisy channels. There are many other candidates for post-quantum cryptography, and researchers are working hard to test their security and efficiency. Another way is to use quantum physics itself to protect our data. This is called quantum cryptography, or quantum key distribution, QKD. It uses photons, particles of light, to send secret keys between two parties. The photons have quantum properties such as polarization or spin that can be measured by the receiver. If anyone tries to intercept or tamper with the photons, they will change their quantum state and reveal their presence. Quantum cryptography has the advantage of being provably secure. It relies on the laws of nature rather than on computational assumptions. However, it also has some drawbacks. It requires special hardware such as lasers and detectors. It has limited range and bandwidth, and it does not prevent man-in-the-middle attacks or key reuse. So which method is better, post-quantum or quantum cryptography? The answer is both. They are complementary and can be used together to achieve the best security. For example, post-quantum cryptography can be used to encrypt the data, and quantum cryptography can be used to exchange the keys. But we need to start implementing these methods now, before I2K arrives. We need to upgrade our software, our hardware, our protocols, and our standards to make them quantum safe. We need to educate ourselves, our governments, our businesses, and our public about the quantum threat and the quantum solutions. We need to invest in research, development, testing, and deployment of quantum-resistant technologies. We can't afford to wait until it's too late. Quantum computers will break the internet, but only if we let them. That's all for today's video. I hope you enjoyed it and learned something new. If you did, please give it a thumbs up and subscribe to my channel for more tech and science content. And don't forget to hit the bell icon to get notified when I upload new videos. Thanks for watching, and see you next time.